Buttons on this one, but the right button is over there. Good. Welcome. Thanks for having me. As he said, I'm Chris. I work for Twitter, obviously. Right? I was just talking to him, and he said he saw me in a pink shirt. I said, I don't think so, because I only have this one shirt. Right? So if you're going to watch a YouTube video where I give a presentation, you will see me in the exact same outfit. So it's very easy to spot me. Okay, so usually I say the most important question is, who in this room has a Twitter account? That's a pretty good outcome, but I think it was like only 50%, so a bunch of people need to create an account. But for today, I think the more important question is, who does not have a beer? Who would like to have a beer of the people who don't have a beer? You should grab one. Or I'll bring you one during the talk. I'll cater you. I'll bring you one. Okay, so the reason I was asking about the Twitter account was the Twitter has a small VM team of about 4 people. We have 2 other people that are doing different things, but we have 4 core people that actually work on the JVM. Yes, I was told not everyone here is Java, right? So who does not do Java and knows a lot about JVM and one? Okay, 1.5. Does not, yeah, right. So I'm talking a lot about the JVM because I'm a compiler engineer, and so I'll explain to you a bunch of things later, and I'll ask you if you know what it is, and then I'll explain it to you. So Twitter has a small JVM team, 4 people, roughly. So we have 3 GC engineers, and they're basically constantly busy fixing you know, the GC issues that everyone has. We have our microservices, and some of them don't work very well, and so they're constantly working on this support-wise, kind of. And then there's me. I'm the compiler engineer, and I do the fun stuff. Okay, so and I travel around to Thalinger and talk to people. I mean, I can turn it back on, but I'm not sure how long it will last.
Let's see how many inches.
I think it's these 2.
Right. Okay, so it takes 3 inches.
3. The answer is 3.
No.
Okay. It's okay. Still working. See? Didn't break it. All right, we were back. Where was I? I can't remember. So everyone got a Twitter account now? Okay. So I do the fun stuff, and I travel around and talk to people about the stuff we do at Twitter. And so if you're going to tweet about this talk, and I encourage you to do that, I hope you tweeted about the previous talk as well. Doesn't seem like it. If you're going to do, please add this hashtag TwitterVMTeam, and then my colleagues back home, they will know that I was actually here. Good. So what's the goal of this talk? You know, the talk name, I saw it was kind of cut off. It's actually a talk name is Twitter's quest for Holy Graal runtime, right? And so what's the goal of this talk? And the goal is to save money, okay? It's definitely a goal for Twitter to save money, but it would also be good if you could then take away what I'm telling you today and save money yourself. You know, not personally at home, well, maybe, I don't know, but at your company, right? And then, you know, maybe the company gives you a bonus or something like this. I don't know. Well, so let me quickly talk a little bit about myself. My name is Chris Thalinger. I live in Hawaii. I don't know if you've been there. I'm running a small conference called Lava 1, which is not so funny anymore now that it's called Oracle Code 1. It was really funny when it was called Java 1 and Lava 1 in Hawaii, right? So it's in January. I don't know. How's the weather in January here? So we were running around in orchards and surfing at that time, I'm just saying. So if you're busy or not busy, if you're free in January, maybe you should stop by. So I'm working on JVMs for a long time, over 13 years now, and almost all 13 years I was working on compilers, JIT compilers. Number one question, who knows what a JIT compiler is? Oh, that's pretty good. I almost don't have to explain it, but a JIT compiler basically in the JVM takes Java bytecode and translates it into native code so that your application runs faster during runtime. So that's kind of the gist of it. So I'm working on this stuff. Back in the day, oh yeah, at this point, I would like to call out people, like old people, right? Who remembers what GNU GlassPath is? Ha, 1, 2, 3. Old people. GNU GlassPath was a clean room implementation of the Java core library before Sun open source Java, right? And so it was a GNU effort to do that. There was also Apache Harmony. They were really the bad guys. Even the Sun guys were better than Apache Harmony. That's not true, but you know, there was always this license war, and it's still going on. And so we always met in at FOSDEM in Brussels. I don't know if you've ever been to FOSDEM. You should definitely go. So there's a lot of beer drinking going on, even more than here, I have to say. And so we were kind of the Wild West, and we were doing all this free Java stuff, right? And then Sun, they were the bad guys. And in 2007, 2008, Sun then open source Java, right? And then suddenly they showed up at FOSDEM, and then they also gave presentations and wanted to, you know, become cool guys as well, I guess. And they were buying us beer, and so we said, okay, yeah, you're cool too. And so they're still coming and buying us beer, and so we let them. Really, that's how it works. And then in about 2009, I thought, okay, yeah, the Sun people, they are actually pretty cool, so I started working for Sun Microsystems. And at that time, I joined the Hotspot compiler team, and I worked mostly on C2. Who knows what C1 and C2 are? Okay, a few people. So Hotspot, you know what Hotspot is, yes. The JVM in OpenJDK. Hotspot has two JIT compilers. One is called C1, or client compiler, and the other one is called C2, or server compiler. You might remember the dash client, dash server thingy. So there are two JIT compilers. There are two different compilers. One, C1, is a high throughput compiler. So the purpose of the compiler is to produce native code quickly. So you get away from interpreting code and run on native code, but it's not optimizing as much. And then C2 is a highly optimizing compiler, and it produces peak performance code so that your application runs really fast. That's how it works. So I was working on C2 most of the time. And then these are kind of the three biggest things I've worked on besides on fixing a million bugs, I think. I was working on JSR 292, which is invoke dynamic, right, for dynamic languages, so the support for that. John Rose and I, we were working this for, I don't even know, a long time, 2-3 years or something like this. I wrote all of the compiler support. I did a little bit of interpreter support, and then there was a first implementation that didn't work so well. It had like a performance cliff at some point when you did too much. So we had to rewrite that whole thing, and we moved a lot of the logic from the VM, from the C++ code into Java, into the core library. And I wrote a bunch of that core library code as well. So if it doesn't work, you technically could blame me. But you know, a lot of people touched the code after me, so I think my code was perfectly fine. Exactly. So then we were doing JEP 243, the Java level JVM compiler interface. We're going to talk about this a little later. JVM CI in JDK 9, which is basically we took, oh yeah, who knows what Graal is? Okay, so that's kind of good that no one, yeah, not really, but you might have heard, the people who put their hand up, you might have heard of the Graal VM announcement, right? I'm not talking about Graal VM. So that's a very confusing marketing term that Oracle Labs came up with. So Graal VM includes a bunch of more things. It includes, Graal the compiler, it includes Truffle, it includes Substrate VM. I'm not talking about these things. The only thing I'm talking about is Graal the JIT compiler, nothing else. And Graal the JIT compiler, I think I'll bring that up later on the slide, I think, is part of OpenJDK now. So that's the only thing I'm talking about. So we took the interface. Graal is written in Java, by the way, if you don't know that. And so we took the interface that Graal had and extracted it out of Graal and put it in the JDK. So that the idea behind it was, if we have the interface in the official JDK, in Oracle JDK or OpenJDK, you could just download a build from the Oracle website, and you can plug in an external compiler. So that was the whole idea. So we put that into JDK 9, and then we did CHAP 295 ahead of time compilation, which is basically using Graal to AOT compile Java code. It's kind of a command line Java tool, really. It's nothing more. It reads in Java bytecode class files, jar files, throws it at the compiler compiles it and spits out a shared library. That's all it does. So since JDK 9, there's also Graal in the JDK, basically. And it was funny, at FOSDEM this year, I gave this presentation, and then I said, well, you can use it in JDK 9 as well. And then later Mark Reinhold came to me and said, well, I didn't know that worked. And I said, well, yeah, So I made it like that. I made it so it works. And now I'm working at the Twitter VM team. Best company on the planet, by the way. I mean, I'm sure this company is good here too, but So everyone, or maybe not, because like 50% didn't have a Twitter account. You kind of know what Twitter is, though, right? Yes. So it's a hugely distributed system. We have many, many, many microservices. The most important ones are obviously the tweet service, reading and writing tweets, user service, everything that has to do with your account, your user, timeline service, building up your timeline, social graph service, the interactions, the who you follow and who is following you. So these are kind of the biggest services we have, biggest in terms of the instance size. Like how many instances are we running of that service? And so we have many JVMs running the service, depending on, is it one of the bigger ones? And it's thousands of machines running thousands of JVMs. So, and we do that in multiple data centers. So it's kind of a big operation, right? We use a lot of open source, but we also do a lot of open source. So we have this GitHub jokes? Anyone? I've seen a couple good ones today, I have to say, on Twitter. Good ones. It was mostly clippy, but so we have this organization on GitHub where we open source all the stuff that we can open source. Let's put it this way, right? We are not open sourcing our IP, but we open source all the frameworks that we use to build stuff on top. Like we have something called Finatra. That's the framework where we build most of our microservices on top. You can download that. So in general, Graal is also open source, and so it's a good fit for us, right? We can pick it up from GitHub, and we can integrate it into our JDK, and then use it. And we're also contributing back to Graal as well. I'm talking a little bit about that later. So we have our own JDK, or VM team, as we call it, and we have our own JDK. So it's pretty much a clone of JDK 8U. We're still running on 8, yes. And the main difference is between like the upstream 8U version and our version is we have CHAP 243, right? We need it if we want to run Graal on 8. We have to have it. So we backported it. We have a copy of Graal in there. We have something called Contrail, which is not that important anymore because, or will not be that important anymore because Oracle open source JFR, Java Flight Recorder, and I think it will be part of 11. I hope so. And then at some point we had a bunch of CMS improvements, but we upstreamed all this stuff. So I should probably take out that line off my slides, but So why Graal? That's a very important question, right? So C2, and I've worked with C2 for a very long time, is very, very complex. It's unbelievable. The problem with C2 is it takes you multiple years to understand how it really works and how it interacts with the VM. So we had this issue when I was still working at Oracle that some people weren't so happy about it. This is live streamed. I have to be a little bit careful what I'm saying here. But some people weren't too happy with how Oracle does business, like engineers. So we were hiring, some people left, and then we hired new people who have not worked on Hotspot or C2 before. And so they started working on it, and they started learning it, and then at some point, they didn't say it, but they quit. And the problem is, these days, you're looking at frameworks and all this stuff that's on GitHub and blah, 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 and you look at it for a week or two or a month or two, and you think you'll understand, right? At that point, you will understand how it works, and you can work with it or even contribute to it or something. With C2, it's completely different. It's like me personally, it took me at least 3 to 4 years to fully understand how it works. And it's for today's society, like instant gratification, right? Like on Instagram, it's impossible. So people left. We hired them, and then they left because they probably thought, oh, I'm stupid, or I don't have the time for this. I don't know what they were thinking, but that's a problem going forward because we need younger compiler engineers to keep the thing running. So the learning curve of C2 is way too steep. There were no major optimizations in the last couple of years. So there were a bunch of optimizations in more the lower level situation, like intrinsics, compiler intrinsics. Intel was doing a lot of work there, right? Intel was is bringing out AVX instructions wider and wider and wider. And its intrinsics are basically handwritten assembly code that then gets compiled into your code. That's kind of what intrinsics are. And so this was more or less the only optimizations we did. There was no improvement of the whole inlining or escape analysis or anything. So, and for a couple of years now. So we need something where we can do these things again. And one of the main reasons why we didn't do new major optimizations was because it's too complicated. No one really wants to touch it and change too much in the compiler because it's been working so well for everyone in the last 5, 6, 7, 8 years, right? And to be honest, almost the whole world runs on Java. Like maybe it's changing now a little bit, but let's say almost the whole world runs on the JVM. It's crazy. So, and in my personal opinion, C2 reached its end of life a long time ago. So, either way. Graal, on the other hand, is much, much easier to understand. For 2 reasons, I think. Number one, it's written in Java. So C2, and especially C2 and Hotspot is written in C++. I mean, maybe some people in here are doing C++ or still can do C++, but younger people, they have no fucking clue what it is, right? So I think that's a big point. And then Graal was from ground up modular designed. So C2 was never that way. C2 is like the thing you don't want to touch because everything tangles into everything else. We've had this many times. And it's all in the bug database. It's open source. You can look at it. You touch something here, and you break something over there, and you have no idea why. That's where the 4 years are coming from. That's what I was talking about earlier. So Graal is very different. It has this modular design, and it makes sure that you don't have circular dependencies between your. They call it modules. It's not really a JDK9 module in that sense, but something similar. So they make sure you don't have circular dependencies or dependencies in directions you shouldn't have, and things like this. And then, very, very important, and we'll be talking about this later a lot, Graal has just a better inlining implementation and as well a better escape analysis implementation. So it's not important that you fully understand what that is, but it's good that you heard it at least once. So I was starting at Twitter about 2 years ago now, roughly, and it was an interesting ride. And one of the reasons why I left Oracle and joined Twitter was Graal, the compiler. That's also one of the main reasons why I'm here and talking to you and talking to all the other people at the conferences I'm going to is we need people to try Graal. We need to throw, you can only run so many times spec GBB with your new compiler until you found all the bugs, right? And it's not getting any better if you do that 1,000,000 times. So what we really need is to run your shitty production code with Graal. That's what we really want, because then we find the problems, right? So that was also the reason why I joined Twitter, because I wanted to go to a company and actually use the compiler in production, like in the real world, not in an isolated lab where nothing can go wrong. So when I joined Twitter, we found a few bugs. So I'm walking you through them. If you don't understand everything, that's fine. I just wanted to show you kind of what they were and how many we found. So the first bug we found was Graal should support the same OSR compilations as C1 and C2. If you don't know what on-stack replacement is, it doesn't really matter. Just follow along a little bit. So if you do a print compilation while you run stuff, you see all the compilations coming out, and then sometimes it says compile skipped. And in this case, it was OSR with locks not supported. And the exception that is thrown looks something like this, which is very nice, because Graal is written in Java, so if something goes wrong, you get a really nice Java exception. And then it says, OK, it happens in the on-stack replacement phase, blah, blah, blah. So you know something went wrong there. And you could technically debug it if you really wanted to. So I discussed this with an engineer at Oracle Labs, Tom. And so after a little bit back and forth, we decided it's not a big issue, because who knows what tiered compilation is? Tiered compilation? No hands? OK. One. OK, explain it. No, I'm kidding. So when I talked earlier about C1 and C2, the way the JVM, or the way Hotspot works today, and many other JVMs do that as well, or VMs even, you start out interpreting your code, right? That's really slow. And then you jump up one tier, you compile it with C1, and you compile it in a way that you collect profiling information, and then you run a little bit, and then until you have enough profiling data, and then you recompile with C2 to actually get peak performance code. And so you're going through the tiers, and that's what tier compilation is, right? So in that case, if we can't compile in the highest tier with Graal in that case, right? If we can't compile it, if the compiler says, I can't do it, sorry, we still have C1 code. So we still have natively compiled code. We're not interpreting in it. So we said, OK, whatever. We try to compile it a bunch of times, and then the VM will say, sorry, and then we run on C1 code. Perfectly fine, because in this particular case, it was, I think it was a core library method, but it was not a really hot one. So it was not important for the service to run on perfectly, basically. So it was fine. But it would still be nice to get it fixed. And then at some point, I didn't even realize, I forgot his real name. I think his name is Leopold or something like this. He fixed it. So, and it was a fix of 1,000 lines of code. So, it was kind of, a medium type of fix. Good. So that one was fixed. That was nice. I tried to, verify that it was really fixed with our service to see if, and then this other one showed up where it says, no on-stack replacement, no generated, right? So we were talking about this, and then Tom says, do I have a mouse here? No. So I have to do this. You wanted the dog? Yeah. So there's a problem with de-optimizing on static field access in the CL_init method, which is the static initializer of a class. And so he says, Tom said, there's a little piece of logic in C2's parser which allows access to static fields within the CL_init for classes which aren't fully initialized yet. So it's a mouthful, but it's basically an issue. When you're compiling the static initializer, you're seeing final fields, but they can't be final yet because you haven't run the initializer yet. So the little piece of code here, the little bit of logic in C2's parser looks like this. That's the C++ method. It's called static field OK in CL_init, which is fine because you are the compiler. You know it's fine. right? You know, okay, when I'm done running my code, this will be a final field, and it's cool. So you can optimize that. And the important comment is this one: better to check now than to de-optimize as soon as we execute, because usually you're not compiling a static initializer. You only run it once, right? How would that ever get hot? So if it's really being compiled or scheduled for compilation, it's either very long, so it takes a long time to run, or it has loops in it, which also means it will run for a long time. So you really want it to be compiled, because your whole, well, maybe not the whole VM, but at least one thread or multiple threads in your system are waiting for this class to be loaded so that they can carry on. So if you would compile that in the way, people probably don't know what de-optimization is, right? Either way. So if you compile it in a way that you would de-optimize, that means you would fall back from the compile code into the interpreter and running slow again. You completely defeated all the point of compiling it, because you spend time to compile it, you run the compile code, you noticed, oh, I can't, so you fall back in the interpreter. Complete waste of time. So all we need is this method in Graal, 31 lines of code, 6 deleted, very simple fix. But we just needed to find this, right? That's the whole point. Good. Then we had this one, ignore the long, but it was a segv, like a crash, hard crash. The important thing here is long-running processes, couple days. That was very annoying, you know. We were running this service and it crashed after a bunch of days, and I didn't know, okay, what am I doing now? So it turns out that we're using something called Heapster, which is an agent, and Heapster is a agent library to do heap profiling, okay? Heap profiling, very important. So what heap profiling means, you're instrumenting the code with some code that that collects the types, the classes that you're actually allocating, right? So that you know what you have on your heap. So remember, Graal is written in Java, okay? So there are things in Graal that are called snippets. It's something like an intrinsic, and snippets are handled very in a special way by Graal itself when it compiles it. So the problem was that Graal used these snippets, and wait, don't I have on this slide? Oh yeah, here we go. Right. So there was a snippet for yeah, I can't remember which it was. It doesn't matter which it is, but the snippet itself used the double dot value off. And the double dot value off does a new. And the new will get instrumented by the agent. So in this particular case, the snippet, you had it compiled basically into Graal, let's put it this way. And then later when the agent instruments the code, the bytecode looks different than the native code. So the bytecode was then suddenly longer than your actually native code, and the bytecode indexes were wrong. So that's why we crashed. So then Tom said, well, we don't have a good way around this. And then Doug said, well, maybe it's time to bite the bullet to parse the bytecodes for snippets directly. That's what they did. Only took 2,800 lines of code to do that. But it was important because a lot of people are using agents in the real world, right? Yeah, SpecGBB doesn't, of course not. But we do, right? We use that stuff. So it was very important to fix that bug. Then we had I was running a service, and I was looking at the log files, and sometimes there was an endless flood of connection exceptions that we were getting, and we really didn't know where they were coming from. The big problem when everyone, when people say, oh, microservice architecture is the best thing in the world, yeah, debug it. Right. You don't know where the connection error comes from, right? It could be you, it could be the other 100 services you're connecting to. So at that point, and I'm really not an expert in doing stuff like this, right? I was only compiler or engineer and not a microservice or whatever. I didn't know what to do. I didn't know how to find that issue. So I knew that I think what happened at this point was we were upgrading our Netty version internally, and I thought, okay, it might be a good idea to run the Netty tests with Graal to see if it will be fine. And so it turns out that Netty buffer test suite failed. I thought, okay, that's interesting. Let's look at this a little bit. So again, I talked to Tom about this situation, and it turned out that 2 bytes, or yeah, it was actually 2 bytes, were written in the wrong order. So if you know the number class, so integer short and all these long, they have a reverse byte method, and that method is being intrinsified by the compiler. So there's some specially, it's not a handwritten assembly code, because Intel has one instruction that does that, right? Reverse bytes. So that's what the compiler uses when you use that method, and it was used in the wrong way. It was short dot reverse bytes, and the compiler screwed up. But this is used all the time. So the question I still don't have an answer for is, why did it fail in this particular case, but not all the other cases that we were using? So anyway, so Tom looked at this issue. 5 changed files, 68 additions of code, 18 deleted, and I think the 68, it was basically a 2-line fix. It included a test case. That's why it was 68 lines of code. And that was it. These were all the bugs we found. And that's more than a year and a half ago now. And since then, nothing. We've not found a single bug since then. And we are running a lot of code on Graal. What are they doing down there?
They're finalizing construction.
Was that? Yeah. I'm wondering, was that finalizing? Was that a pun? Finalizer? Jeez. Yeah, okay. Yeah, no, I got it. That was a good one. Almost as good as the GitHub jokes. So, contribution. So far, we only contributed one thing because, as I said, no, maybe I didn't say it, but I said it earlier. I joined Twitter for a reason, right? So to run Twitter on Graal, to test Graal and make Graal a more mature compiler. Turns out the 2 years I'm at Twitter now, I wasn't doing software engineering. I was doing social engineering. And the reason for that is, you come to a company and, we could argue that Twitter is a kind of important service that should stay up and not, go down. It's not that easy to go to service owners and tell them, hey, I have this new compiler, it's experimental, no one's using it in production, would you like to try it? Yeah, that was tricky. There was a lot of social engineering hand-holding going on, so that's basically what I was doing all the time. So the only thing we were doing, or what I was doing, was implement support in Graal, or partially, it's still not fully done yet. And there's something called compact strings since JDK 9. And we knew we wanted to move to 9 before Oracle decided, okay, 9's not an LTS, and they screwed us all. But at that point, we still thought, oh, we're moving to 9. And so I knew compact strings would come, and I knew some services would use it, and there would be a big performance hit if we didn't have the support in Graal. And so I started porting one over because it's a little unfortunate, but Oracle decided, because C2 was a too stupid compiler to optimize the code if it was written with unsafe. That would have been much, much better, because then we could have reused the code for every compiler we have. But C2 couldn't handle it, and so Oracle decided to write handwritten assembler code. And that means that handwritten assembler code we have to port over to Graal as well. And there's an optimized intrinsic for this, uses SSE, AVX, AVX 512, you name it, all the bells and whistles. And we needed that in Graal as well. This is just a benchmark showing, if you look at the 3rd line here, that was before and that was after, right? And so on the bottom table is basically the same as with C2. Graal's not better here or anything, right? It's handwritten assembly code, it's the same thing. It's just, it should be the same. So we did that. I did not really finish it because I started traveling too much and going to conferences, but Dmitry Samasov, he then eventually finished it, wrote a test case for it. It was about 1,000 lines of handwritten assembly code that we had to port over. But it was more like copy-paste, not really doing work. But there's still, I think, four smaller methods left that we have to do. And I have to hurry up with that because I think the train for 11 will leave soon. So we should get that in before 11. I'm wasting a lot of time here, but I think you all still happy. Your beers are still full. Probably not. Here's the important part, or the interesting one. So we're talking numbers. So you'll see a bunch of graphs, and then I'll tell you how much money we save. So we're talking about the tweet service, which is reading and writing tweets. That's all it does. It's a Finagle thrift service. So Finagle is one of these frameworks that we open sourced. It's an extensible RPC system for the JVM used to construct high consortiums, whatever. You know, we're doing this stuff. And the important thing on this slide is it's almost entirely written in Scala. It's like 92% it's Scala code. And so the test setup I used was I used a dedicated machine for the benchmarks because if I used it in our production cluster in the data center, we're running multiple services on one machine, right, to utilize our machines, and then there's a lot of cross-talking going on, and so it was not that easy to totally isolate the performance improvements we were seeing. So I'm using dedicated machines. And all instances that we have, so we have a dedicated machine per instance per / configuration, and all instances receive the exact same requests. Very important, not the same number of requests, the exact same request, because it's important if a tweet is 1 character or 280, right? It's very different in terms of how much memory you have to allocate to process that tweet. Okay, so then we were using JVM CI 0.30, not important, Graal, not important. We used it in the default tiered setup. I explained to you what tiered compilation is. Now everyone should know. With C1 and Graal, okay? And then Graal bootstrapping is, since Graal is written in Java, and we are still running on Java 8, where there's no AOT compilation, we have to compile Graal itself when the VM starts up, right? When it gets hot and starts compiling stuff, it will compile itself. That's what's called bootstrapping. That can be an issue, but mostly it's not. If you watch my other talk on YouTube, I think I'll mention it later, I'll show you that it's not an issue. For most people, it's not an issue. And the reason is because C1 is such a quick compiler that it's fine. Okay, so, but if it would be an issue for you, and you run on JDK 8, on JDK 9 or later, you could AOT compile Graal, and then all this is a non-issue. Okay, graphs. That's good. It's good that it's cut off here, but this is 24 hours of tweets, reading, and I'm showing you C2 in blue. It's not that important because there's no y-axis anyway. So blue is C2, then we have Graal in orange, and then I threw in JDK 9 as well just to make sure. When I was doing the experiment, I was still thinking we're moving to 9. So I was throwing them in as well. As you can see, they all received the exact number of requests, and as you cannot see, and I'm happy about it, is there's no y-axis, and that's because I'm not allowed to tell you. That's confidential information I'm not allowed to tell you. Okay, so let's go. The tweet service uses parallel GC, so we're looking at parallel scavenge cycles here. It's a moving average of 60 minutes, so it's a little smoothed out and it's easier to read. Kind of looks like the graph we saw before, right? The more tweets you do, the more memory you allocate. Makes sense. I said earlier that Graal has a better escape analysis implementation, so that means it should be able to get rid of object allocations, get rid of more object allocations than C2. So what we would like to see is like a lower graph here for Graal, which we do. Okay, that's great. That's really what we want to see. This is JDK 9. This is JDK 9, so it's about the same. And it's roughly 2.5% less of GC cycles. It's not a lot, right? But it's still nice if you don't have to do the GC. That's a lot of time. And especially, that means that you're not producing as much garbage, which also means you're not allocating the object. That's also where you save a lot, right? The object allocation takes a lot of code in compiled code. It takes a while. If you don't have to do this, your code is a little bit tighter and it runs faster, okay? So this is very good already. Then I have to talk about old gen usage a little bit because and probably at your company as well, if you have SREs or something like these, people who take care of services, they monitor the services really closely, right? And so some of our SREs, they were screaming out, oh my God, memory leak. And I said, no, not really. It's just 40 megabytes more. So there's a 40 megabyte memory usage more in the old gen. And the reason for this is Graal is a Java application. It has some state, right? It needs to store some stuff. So it's using up a little bit of memory. But it's 40 megs, right? It doesn't matter how big your old gen is. If your old gen is 100 megs, it's 40. If it's 2 terabytes, it's 40. Doesn't matter. It's just the state is the same. There's also the same is true for Metaspace, because you have to load some classes as well. But for Metaspace, I don't have a pretty graph, so just believe me. And Metaspace is between 20 and 30 megabytes. So that's what you lose. This is the important one. User CPU time, because if you can reduce user CPU time, then you can save money. Because if you can process more tweets or whatever you're processing more requests with less CPU, that means you could actually do more, right? And then reduce the instance size of whatever you have. So you would like that to be lower, and that's definitely the case. This is about the same as the blue one, C2, and this is for 9. And I put this in a ratio, and now it would be good to see it over here, because then you kind of can't tell. You see that? Okay. But it's not, so it's roughly 11% less. And 11% is huge, right? I mean, I don't know how many compiler engineers are in this room, but if you worked on a compiler before and you tried to optimize something, you have a good idea for an optimization. If you get 1%, you're happy. If you get 2, that's great. I mean, but 11 is unbelievable. So 11% reduction is, when I saw it, I didn't believe it, to be honest. But it's true. It's really true. So the tweet service right now runs 100% on Graal in production for at least 10 months now. It might be 11 now. I can't remember. What month is it now? June already, right? Yeah, it could be 11 months now. And without an issue, right? I didn't lose any tweets. Did you lose any tweets? It's Twitter running fine, I think so. Are you reading all the Trump tweets and the GitHub tweets? Yeah, no, it's running fine. So, and it's not only the tweet service, where all the other ones, all the big other ones that I was mentioning, they're also running on Graal. 100% in production since 10 months, 11. No issue. So I was interested in this. If the improvement, the 11% that we're seeing, if it's coming from escape analysis, if the better escape analysis implementation is responsible for this big reduction in CPU time. And so I was running the experiment, and I turned off escape analysis for both compilers, for C2 and Graal. And this is a slightly different graph. It's again 24 hours. But I had to rerun the experiment, and I'm only doing C2 and Graal in this case. And I turned off escape analysis. So what we want to see here is exactly the same number of GC cycles, because that means they're allocating the same amount of memory, which they do. Perfect. So the setup is fine. And now let's look at user CPU time. But it's still better. And if we put that in a ratio again, we see it's still 5%. So just the implementation, the inlining implementation of Graal gives you already 5%. And then the remaining 5 to 6% is getting rid of all the object allocations. So inlining is the mother of all optimizations, right? If inlining works well, you can produce tighter code, and inlining opens up the whole world for all the other optimizations to work well. So this is great. I was happy about this. So how much money? How much money do we save? I couldn't show you a y-axis. Do you think I can tell you how much money we're saving? Of course not. So I'm making up this fictitious company. I don't know. Some of you might know how many servers you have. Some of you might know how much money you are spending for running your business. So I'm just making this up so that people kind of understand how to get a feeling for it, how much that could be. So I was looking up cloud hosting providers, and they're all kind of show it in different numbers, and it's a little hard to read, so I calculated it out for you. It's between $72 per year per CPU core and 210. Okay. Number one takeaway, if you pick the wrong cloud provider, doesn't matter which compiler you use because you're screwed anyway. So the average would be $127 per year per CPU, because we're making everything up, so it doesn't really matter if it's correct or not. So how many cores are we talking? Okay, so I was looking up, and I found this Bloomberg article from 2014, which is now already 4 years old, and it talks about Amazon over 1.5 million servers, and Gartner says maybe 2 million, and then it says over here, Microsoft has 17 regions, and Steve Ballmer said the company had over 1 million servers with its data center infrastructure, and that Google had even more. Ridiculous numbers are these. I mean, Twitter is not as big as, let's say, Amazon or Microsoft and Google, but we have a good size. But this is ridiculous because we're talking servers here. A server has usually, what, 24 cores? So it's a lot. So we're picking a random number of 10,000 servers, and then it's usually 24 cores. So we say $127 per year per CPU core multiplied by 24 multiplied by 10,000 is $3 million just to run whatever you're running, right? Let's say you're running Twitter. I don't know what you're running. If you can save 11% of that, that's over $300,000 per year. That's more than I get paid. I don't know how much you get paid, but it's more than I get paid. Can we squeeze out even more out of Graal? Like, can we get even less CPU utilizations than we already get out of? I mean, the other experiment I did that was like out of the box. I didn't change anything. I was just turning on Graal. That was all that I was doing. So, easy job. So it turns out we can. So I was sitting down an afternoon, fiddling around with some inlining parameters that Graal had, and like 2 hours or something. I can't remember, 2 or 3 hours maybe. And so I was running this experiment. That's actually the same as the first one we've seen today. And I've added this experimental color in purple here. And I've just adjusted some of the inlining parameters. Inlining a little bit more. That means escape analysis can work better and so on. So we're looking at the same graph of scavenge cycles again, and it's slightly better. That's good. How much is it? It's like a 1.3% more, which is, a lot. It's like, what, 50% more. That's good. If we look at user CPU time, it's also less, which was expected. And this is an additional 2%, which was, how much was that? Like $30,000, $60,000 per year just by playing around a little bit with parameters on the command line. That's not what a human should do, right? But I think there's something called machine learning. I don't know exactly what that is, but I think machines could do this for us. And that's something we are actually doing right now. So we have something called AutoTune, and we're using AutoTune to tune different JVM parameters, like GC parameters, but we also do it for Graal. I'm not telling you too much about it because that will be my next talk then. Not today, but the next I'm preparing, and then I will tour around. I'll come back and tell you about that next time. It's very exciting, but anyway, it's more than 2. That's all I can say. So any official support? I think that's a very important question. I'm probably going over time, but it doesn't matter, does it? Does not. Yeah. Hey, the sun's still up, man. It can only be, what, 6 p.m. or something? I don't know. So I'm pretty sure your company does not have its own VM team. Right. So official support for you is probably important. So as I said earlier, JDK 9 contains already Graal because of AOT. And you also can use it as the JIT compiler. It's not really supported. As I said, I made it so that you could use it. But it's even better because in JDK 10, Oracle officially put Graal in the JDK, into OpenJDK. Under JEP 317, experimental Java-based JIT compiler. And that's, the best support you can get today. If it will not happen, but if your system goes down or your data center burns down, Oracle will not pay for that. But at least if you find a bug or something, or you have an issue, they will help you out, right? Okay, that's already good. Then how do you use Graal? And that's the thing I was talking about earlier. So there's this other talk called Graal, how to use the new JVM JIT compiler in real life. Very important, because the fact that Graal is written in Java, it has very different properties than the compiler written in C++. And if you understand that, then you're using it right. So just search it on YouTube. There are a bunch of versions of this talk on YouTube already. And then there's something called Project Metropolis, which was proposed September 30th last year by John Rose. And the important thing here is blah, 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 advanced Java. John likes to call it Java on Java. I was never okay with that term, but he calls it Java on Java. Implementation techniques for hotspot. Our starting point is earlier proposals for using the Graal compiler and AOT static compilation technology to replace the hotspot server compiler. So to replace C2 with Graal, yay, that's what I want. And possibly other components of hotspot. So what we're trying to do is to write more of hotspot in Java, because it's easier sometimes to do it. Not all of it, like the GC, don't write it in Java. Worst idea ever. People have tried it. Maxine, ChikeSRVM didn't work. But the compiler is the perfect example to do this. And it works perfectly fine. And you can do other things as well. I'm hoping we can do the interpreter, and I'm pretty sure it's possible. There are ideas to do this, but that would be great. OK. So I have to say this, because this all looked great. Right, and you probably can't wait to get back home and try this all out, and I can't blame you. So I said most Twitter services, maybe I didn't say it, most Twitter services are written in Scala. So we only have a handful that's written in Java. And the fact that they are written in Scala is the main reason we are seeing such a big improvement. Scala, the way Scala is compiled down into bytecode, is like the resulting bytecode is more complex than for Java. It's like I like to say Java bytecode is very flat and static. It's very simple. Scala is the worst, to be honest. But Graal can handle it really, really well. So if you're doing Java, it's a different story. With Java, my rule of thumb is it's a 50-50 chance if it's better for you or not. I've seen cases where it's better. I've seen cases where it was much better. I've seen benchmarks especially where Graal was worse than C2. And one of the reasons for this is, and I think it's the main reason, for the last 10 years at least, C2 was optimized for Java code. And more importantly, vice versa. The Java code people wrote was optimized for C2, because they wrote it in a way that it was running the fastest, right? And that doesn't necessarily mean that works well with Graal. So, you know, your mileage may vary here, but it might be possible that you're seeing some improvements there as well, but not 11%. I'm sorry. Good. I'm actually done almost. So the summary of this talk is very simple. That's it. These are the command line options you need to use to turn on Graal. That's all you have to do. If you watch my other talk on YouTube, you will see I'll do everything from scratch in my other talk. I'll fire up a completely empty cloud instance that doesn't even have Java installed, and I show you everything that you have to do to run with Graal. Switching to a new JIT compiler is very different. Some might think, I don't know. Some might think, oh God, if I'm switching GC, that's the worst, right? That's very different. A GC implementations have very, very specific properties, and they're very different from each other. For the compiler, it's a completely different story. You compile code. That's all you do, right? So you can turn this on. I'm pretty sure it will not crash. If it does, I would be very happy. I would encourage you to file a bug on GitHub, and then we'll fix it. If you have a performance issue, also report it, and we'll try to fix that as well, because that's what we want. I told you, I'm here to encourage people to try it. You know, go home, try your pet project, or try your, I don't know, you're probably not running JDK 10 in production or something, but you know, if you do, hey, flip the switch and see what happens. So please do. And then let me know. This is my Twitter handle, Chris Thalinger. Tweet it out. Let me know if it works or not. And that's it. Thank you very much.
We have a bit time to squeeze in a couple questions. Maybe even more than that. So, maybe. All right. Here you go.
Yeah, I have a question, maybe more philosophical, historical.
Ooh, I'm up for that. Should we grab another beer and talk it out?
Maybe.
Okay.
When a new programming language appears, core team has main goal that they should write compiler use the new language. It's like kind of maturity milestone. It's very interesting why for Java is different. Only after 21 years, Java community starts to make some action to have own compiler written on Java.
It's true, but I'm not sure if I'm, if I understood you wrong, but the source level compiler, Java-C, is written in Java for always. That's the main difference. Most languages don't have their own VM or JIT compiler. Most new languages run on the JVM already, right?
No, JVM language is kind of, Kotlin, they have own compiler written on Kotlin.
I understand. Yeah. Don't confuse the source level compiler to the native compiler. These are two different things. Java-C is written in Java forever, like since day one. But the JIT compiler that produces the native code, that's something very different. But Kotlin doesn't have that because Kotlin's just using the JVM.
I mean that's Java have compiler, one write on Java,
Right.
one C2 write on C++.
Yes.
Only after 21 years,
Yeah.
we start to write the main part on
I understand,
Java.
and I'll answer that question too. I just want to make sure that you understand that the source level compiler is something very different to what I was talking about. Okay, good. The reason why it's happening now is number one, what I was talking about earlier. It's so complicated and we can't train new people, right? 10, 15 years ago, there were people who were still doing C++. Today, not so much. The other reason, and I think more importantly, is you have to have some pieces in place that you can do something like this. And AOT is a very important key point. The problem with AOT compiling Java code is you can do it with Substrate VM, like what Graal VM does. It basically does a closed world analysis of the application. But that's only coming up now, and it's still complicated to do it because Java is so performant because it does runtime optimizations. If Java doesn't have runtime information, what types it's using and which method is hot and invoked a lot, it's very slow if you compile it. You know what I mean? So if we would have done it 15 years ago, it wouldn't have worked. So we needed the time to actually get there. Does that answer your question? It's not very satisfying, I understand, but
yeah, I understand it's only after some time community understands that we need to change it. But we create, the community creates C2 and we have the problem with C2 that it's a big monster and we took him in one place and reaction in another place.
yeah, but I mean C2 is what, 15 years old now or something? The first 5 it was probably fine, right? And then you know how old software looks like. It's getting worse and worse and worse. So at some point you have to, switch it out with something new. And that's what we're trying to do, and we're not even there not nearly. It's like this will take another, depending on you, right? If more people use it, and if we can test it more and get it more mature now, we'll get it sooner. If people don't do it, we'll see. It's in your hands. Was that philosophical enough for you?
Maybe an unrelated question to your work, but is Twitter still happy with Scala?
That I don't know. I really don't know. And the reason I don't know this is I cannot write a single line of Scala code. I don't have to, because everything I see is Java bytecode. So I really don't know. The only thing I know is we're kind of involved in the Scala whatever community they have, and we have some people that are involved in this community. I think so. I don't see a trend towards something else. So, yes.
Especially that, as you said, Graal's way more efficient compared to Scala than Java.
Exactly. Exactly. More questions? Don't be shy.
Looks like you made it all. Why you cut your hair?
Well,
You're from Hawaii.
I know. Well, you know, when you get older.
Yeah, I know.
Okay. Good. I'm glad we discussed that philosophical topic.
Apart from that, looks like you made it all so clear. Thank you for that. It was really awesome. That's a bit.
Oh.
A little present.
All right.
To you.
Thank you very much.
Thank you.